Hello AP Physics 1, it's Mr. Ng with your lab instructions for your T-pose lab. So this is basically the driving question of your lab. How do mass and radius affect the moment of inertia? Really, we just want to know the nature of the moment of inertia. And in many ways, this is like your broom lab, the lab where you were rotating those sticks all over again. But this time, instead of you shaking the stick, we're letting a mass shake the stick, and that way we could have quantifiable data. But really, we just want to know what matters with the moment of inertia, right? Is it mass or radius? Well, they both matter, but it's more like which one might matter more, right? Which one changes your graph more? What kind of relationships does mass and the moment of inertia have? What kind of relationships does the radius of those masses have on the moment of inertia? That means today you got to set up your variables. Same rules apply. Make sure you have multiple trials. Make sure you have 5 data points at least for each type of question. So here, for your independent variables, you really only have 2, right? You might change the mass, right? And then when you change the mass, you got to keep them at the same radius. I don't think I need to tell you that, right? You should only change one variable at a time. So maybe put both masses in the center of your arms, or maybe at the far ends. It doesn't matter as long as you don't change the radius while you go through your 5 trials with different masses. Same thing goes the other way around. You should also test out your radii, right? How does the radius matter? So you're going to have the same mass and move it along different radiuses. That part's easy. We know what we're going to change. We know our independent variables. Our dependent variable, that's a little bit trickier. That's going to take a lot of math. Our dependent variable is actually the moment of inertia. It's I. We want to find the moment of inertia. But the thing is, that's hard to find, right? The moment of inertia takes a lot of math to find. So we're going to use an equation that looks like this. Recall that torque is equal to force, the perpendicular force, times r, right? But there's another equation that I taught you in this lesson where torque is also equal to the moment of inertia times alpha. If you recall, this looks a lot like F is equal to m times a. Look, torque is the rotational version of force. I, the moment of inertia, is the angular version of mass, and alpha is the angular version of the linear acceleration. Right? So this is the equation that we're going to use to kind of go through our lab. This is kind of our backbone equation. So here, that means we can solve for I. I is equal to torque over alpha. But that's a lot of work. Because number one, you got to find torque, right? So you need to figure out how to do that. And then you got to figure out the alpha of it. So let's walk you through that. This lab takes many steps to find that moment of inertia. It takes kind of 2 bodies of work. Number one, take some time and find the torque for each trial, meaning maybe do a free body diagram. You only need to do this once. And then from that free body diagram, what perpendicular force is on that T-pose? What's pulling it? What's that perpendicular force? What's it called, and what is its value? And then when we know that perpendicular force, how do we convert that perpendicular force to torque? Think about it. Figure that out. I can't tell you. And then, so once you do that, that's part one. Keep in mind that I is equal to torque over alpha. So first do that. Find the torque. Then you need to find the angular acceleration. So can we find the tangential acceleration? You know, what kind of equation do we have to find the acceleration of something falling, given a distance, 1/2 at squared? And then how do we convert that tangential acceleration to angular acceleration? So first find A, and then convert that to alpha. That's going to take a lot of discussion and work on your end. So talk to each other, figure that out. And then finally, so that's part two. Once you have both, divide them And that's how you're going to find your moment of inertia. And this is your dependent variable. You're changing your radii. And for each trial, you got to calculate an I. It takes a little bit of data, all right? It's not going to be like one simple little measurement, okay? Hey, thank you very much for watching. Good luck on your lab. Go slow on it. You have many days on it. Figure out what you're going to do, but really figure out how are you going to calculate I. What measurements can you do to calculate I? And I will see you soon.